Astronomers make stunning discoveries in largest ever asteroid sample. Astronomers have just begun analyzing the largest asteroid sample ever collected, and they've already uncovered some exciting surprises. This precious sample comes from Bennu, a near-Earth asteroid that passes close to Earth about every 6 years. Bennu is like a time capsule from around 4.6 billion years ago, holding within it the untouched history of the early solar system. What makes Bennu so special is that it contains the very materials that were present when planets like Earth were first forming. When asteroids crash into Earth, the intense heat and pressure from atmospheric entry and impact significantly alter their original composition. This contamination makes it difficult to study the pristine materials that could unlock secrets about our solar system's earliest days. However, by collecting samples directly from an asteroid in space, scientists can examine these ancient materials in their pure, unaltered state. That's where NASA's OSIRIS-REx mission comes in. When NASA launched the mission on September 8, 2016, it had 3 critical goals. The first was to collect samples from the surface of Bennu, aiming to bring back 60 grams of material. The second goal was to better understand Bennu itself, mapping its surface, studying its geology, assessing its composition, and determining its potential as a resource for future space exploration. Finally, the third key objective was Earth's impact hazard assessment. Bennu is a potentially hazardous asteroid. On September 25, 2135, it will make a close flyby of Earth. Our planet's gravity will tweak Bennu's path, making it a challenge to calculate its future trajectory. That's because, in addition to gravity, asteroid can be pushed around by non-gravitational forces like the Yarkovsky effect. When sunlight strikes a rotating asteroid, the day side heats up. As the asteroid turns, the night side cools down and releases the heat, exerting a small thrust that can change its direction over time. Because we don't know exactly how the Yarkovsky effect will perturb Bennu's orbit, we have limited knowledge of where Bennu will be as it approaches Earth in 2135. Scientists thus have to consider a range of possible trajectories, depending on how strongly the Yarkovsky effect is pushing on Bennu. A few of these trajectories line up with regions of space called gravitational keyholes. If Bennu were to pass through a keyhole, Earth's gravity would bend its path in just the right way to cause an impact on a subsequent orbit late in the 22nd century. The odds of this actually happening are quite low, but scientists want to know as much as possible. The OSIRIS-REx mission, a historic sample collection. The journey to Bennu took OSIRIS-REx over 2 years and 4 months, spanning an incredible 1.4 billion miles. On December 3, 2018, the spacecraft finally arrived at its target, entering orbit around the asteroid. Once there, OSIRIS-REx began an extensive series of surveys and mapping activities to study Bennu's surface and identify the best location for collecting a sample. The mission's most exciting and nerve-wracking part came on October 20th, 2020, during the sample collection event. The spacecraft used its touch-and-go sample acquisition mechanism, TAGSAM, which briefly touched the surface to collect the sample. TAGSAM is a robotic arm attached to the spacecraft's main body that collects material from the asteroid and stores it in the Earth return vehicle. Since Bennu is a small asteroid with just a half-kilometer diameter, the arm had to collect the sample with almost zero gravity. OSIRIS-REx had just one chance, and there was no margin for error. When the spacecraft made contact with Bennu at a site called Nightingale, a burst of nitrogen gas was used to agitate and lift surface material into the sample collection chamber. The minimum sample size requirement was 60 grams. However, in the brief 6-second contact with Bennu, OSIRIS-REx collected 121 grams of the sample, twice what NASA had anticipated. The return to Earth and initial discoveries. OSIRIS-REx departed from Bennu on May 10, 2021. After almost 2.5 years, on September 24, 2023, the spacecraft reached Earth vicinity and released a capsule containing the asteroid sample. The capsule entered our planet's atmosphere at 7.5 miles per second and deployed a parachute to slow its descent. The capsule landed safely at the Utah Test and Training Range, where it was recovered by NASA personnel. A couple of days later, scientists at NASA's Johnson Space Center in Houston opened the lid on the sample return canister. They were met with a sight that both surprised and excited them. The first thing they saw was a layer of dark powder and sand-sized particles on the avionics deck of the sample canister, material that belonged to Bennu. This dust not only coated the interior of the canister but also extended to its exterior, including the deck where the electronics were housed. The dust had escaped from the canister through tiny openings between the lid and the body. According to NASA, upon its touchdown on Bennu, OSIRIS-REx's brief contact generated a shockwave that spread across the asteroid's surface, resulting in the expulsion of certain materials into space. Some of this material trailed behind OSIRIS-REx as it retreated from Bennu and stuck to the spacecraft's outer surfaces. Additionally, a portion of it entered the sample canister through the open flap, mingling with the material gathered by TAGSAM. Initially, this seemed like a cause for concern. However, the bulk of the Bennu sample remained securely sealed inside, and the extra material provided an unexpected bonus: additional asteroid dust for researchers to analyze. Bennu's origins: a water-rich, geologically active world. After nearly a year of studying the samples from asteroid Bennu, the findings are turning out to be more surprising than expected. The studies suggest that Bennu came from a water-rich, geologically active world. This ancient body might have contained the building blocks that eventually led to life on Earth. Bennu's parent world may have been very similar to early Earth before life began. The discovery of volatile chemicals like ammonia, a very unstable compound, suggests that Bennu didn't form in the asteroid belt between Mars and Jupiter. Instead, its origins likely lie much farther from the Sun, perhaps near or beyond Neptune. The sample from Bennu is also rich in clays and minerals that show clear signs of having been changed by liquid water. Some of this water evaporated, leaving behind salt, which suggests that Bennu's parent body once had a warm, water-filled environment. Evidence points to the existence of hydrothermal systems on Bennu's parent body, likely powered by the melting of ice, which was driven by heat from a warm geological core, probably heated by the decay of radioactive elements. Based on these findings, Bennu's original body was likely at least 6 miles wide, possibly even bigger. In February, the mission team made yet another intriguing discovery: phosphates in the Bennu sample. Similar phosphorus compounds have been found in the warm, liquid oceans beneath the icy crust of Saturn's moon, Enceladus. This again hints that Bennu could be a fragment of an ancient ocean world that might have once contained some of the essential ingredients for life. How Bennu broke away and its connection to life on Earth. One leading theory is that around 3 billion years ago, Bennu's parent body was shattered by a massive collision. The impact sent fragments scattering through space, and one of these fragments eventually became Bennu, migrating into near-Earth orbit. This long journey from the outer solar system may have been crucial in delivering water and organic carbon compounds to rocky planets such as Earth. The analysis of the Bennu sample could also solve one of the biggest mysteries of our planet: the origin of water. For a long time, scientists thought comets, known for their water-rich composition, were the main source of Earth's water. However, recent research has shown that the chemical makeup of water from comets doesn't match the water in Earth's oceans. Instead, it's the water found in soggy meteorites and water-rich asteroids like Bennu that provides a closer match. But Bennu's contribution might extend beyond just water. Its parent body also contains a variety of organic compounds, including amino acids, which are critical building blocks of life. Among these, researchers have found uracil and thymine, key components of RNA and DNA, the molecules essential for life. Looking ahead, OSIRIS-REx and the future of asteroid exploration. Looking ahead, OSIRIS-REx is entering an exciting new chapter. After successfully returning samples from Bennu, the spacecraft has been renamed OSIRIS-REx and is now set to rendezvous with another near-Earth asteroid, Apophis, in 2029. This extended mission will give NASA the opportunity to explore Apophis up close, continuing its investigation of asteroids and enhancing our understanding of these ancient space travelers. By studying both Bennu and Apophis, scientists hope to unlock even more secrets about the origins and evolution of our solar system. The discoveries from Bennu remind us of Carl Sagan's profound words, "We are made of star stuff." The very elements that form planets and life itself were forged in the hearts of dying stars, reminding us of our cosmic origins. Thanks for watching.